Good evening. Sorry for the delay. This is 8.3. We are going to prove triangles are similar. So this is the part of the unit where we are going to do a proof. So let's recap the definition of the proportion, which angles are going to be congruent, and which angles are going to be proportional if these two were similar. So in this case, when you look at it, angle A would be congruent to angle D, angle B congruent to angle E, and angle C congruent to angle F. When you look at the sides that are proportion, AB would be proportional to DE, and then BC would be proportional to EF, and finally AC would be proportional to DF. So as long as the ratios simplify to the same thing, then you're going to have the two triangles will be similar to each other. So what happens here is this theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the triangles are going to be similar. So this should make sense. So if we have two triangles, and you know one triangle is 40 degrees, and you know the other angle is 80 degrees of one triangle, and then for the other triangle, one angle's 40 and another angle's 80, you know that these two triangles that you see here are going to be similar to each other. Not necessarily are they going to be congruent, but they'll be similar to each other because one could be smaller than the other, and we've seen that in class. So you don't need all three because we automatically know the 180 rule, so this angle is going to be congruent to this angle because of what's left over out of 180. So instead of writing out the whole proof, what you're going to write out is angle, angle, similarity. So angle, angle, squiggly will give you that. This one right here, I'd probably say, is almost all of the proofs. Okay. The other two are used less, and the only reason for that is by what's given in the information. The second theorem says if the corresponding sides of two triangles are proportional, then the triangles are similar. So this case, you need all the corresponding sides. Well, how many sides does a triangle have? 3. So you have 1, 2, 3 S's squiggly. So it's SSS similarity. And then the last is if two corresponding sides. So you need two corresponding sides. And the included angle. So this side proportional here. This side proportional here. The included angle is the angle in between those. Now they would be similar. So side, angle, side, similarity. What I mean by that is if you're not given in the given information these ideas of sides being proportional, then you're not going to use one of these. You're going to end up using the angle, angle, similarity. So looking at example 1 here, we're given that this is a trapezoid with the bases here and here. What do you know about a trapezoid? That's right, it's over there off by itself in the family tree, and only one set of sides are parallel. So these lines are parallel, which hence then brings us to the idea of, that's right, parallel lines, which give us some type of angles, either congruent or supplementary. So if this line is parallel here, and we use this as the transversal angle up here, which I'll call 1, and the angle down here, which I'll call 2, are going to be congruent to each other. Okay. Then if I use a different transversal, so let me change colors here, and I say this is the transversal between this line and this line. 3 and angle 4 are now congruent. Our goal is to prove that this triangle here and the bigger triangle down here are similar. Well, what did we just learn? What's the one that we're going to use the most? The angle-angle similarity. Angle, angle, so that's one angle. Angle, angle, there's two angles. So now we can prove that these two are going to be similar. What does it look like? We're going to start with the trapezoid. So we got trapezoid TVPX. Okay. Then we're going to use its definition and prove that TV is parallel to XP. From there, we're going to get angles. What we drew in was angle 1 congruent to angle 2. Well, what kind of angles are these? Well, do I jump over the line? Yep. So they're alternating. Are they in between the parallel lines? So they're alternating interior. Same thing. 3 and 4, same idea. What do we have? We have two sets of angles. By reason 3, we can prove triangle TVY is similar to triangle PXY. 3 reasons. First one, just go definition of trap. 2, if parallel, then alt interior angles congruent. And 3, we finish with our angle similarity. I hope it's making sense to you, because we will have a homework assignment using predominantly proofs. There will be a proof on the assessment coming up. So, in the second one here, we see this proportion. How many sides do we have? 1, 2. So we don't have all 3. So predominantly, we're going to be using, if the sides proportion, we're going to be using one of the 3 up here. Well, which one has 2 corresponding sides? Well, then that's the one that is directing us towards is the side angle side for it. Okay, so our goal is to prove triangle GHM is proportional to GJK. Okay. Well, let's see here. We know that GJ, this side here, is similar to HK. So this side here, which is not part of the triangle I want. And then I got GK, so this side here, the big side, similar to GM. Well, those are good. What I ultimately want is I want GJ similar to HG, because then it helps me out. And then I also have these 2 angles congruent from the given information. Well, when I notice that, what do you notice about this triangle here? If I redrew this triangle over here, GKH, this angle is congruent to this angle. That's what I'm looking at. Well, if I know that, this side would be congruent to this side. So these 2 sides are congruent. And if they're congruent, that means this side is similar together with that. So now we have the 2 sides we need being similar. We need the given angle in between them. Where's the angle between this side and this side? Well, that's G. Wait a second, G's in both of them. So what happens with G? You got it, reflexive. So we're going to have a reflexive angle. I haven't seen that one in a while, but it's still there, still exists. So how is our proof going to look? Well, let's start out with that angle 1 is congruent to angle G. From there, we could do if angles then sides, and we were able to say HG is congruent to HK. From there, if I substitute GJ over HK equaling GK over GM together, I do a little substitution here, I can get what I want, GJ over HG equaling GK over GM. So there's my double proportion. I get angle G congruent to angle G, and I can finish it up with reason 4. The triangle GHM is similar to triangle GJK. Alright, reason 1 was if angles then sides. Reason 2, we did a little substitution here. Reason 3, reflexive. And angle 4 is side angle side similarity. So my warning to you is before you close up here is that you should know which one you're using. Like I said, angle-angle similarity is probably the most common one to prove the two triangles. You even need to do that before you want to solve for x and set up the proportion, is the idea. Side, 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 you need to have all three proportions given to you, so very rare is that happening. And then we saw a proof with side, angle, side, and you saw the given information where two of them were there. So sorry for the late posting. Have a good evening, and we'll see you tomorrow.